Wine and vinegar, depending on the situation, is a grandfather's favorite, right? I mean, who hasn't heard a grandparent drop the classic? Back in my day, we used to make this from scratch. So let me ask you, ever wondered, how do I make wine and vinegar? Well, dear friends, set aside because I have the answers. Spoiler alert, it's better than you think. First, let's kick things off with some history. Buckle up because we're about to jump back to the past. According to archaeologists, the earliest evidence of wine was in Mesopotamia and the Caspian Sea around 5000 BC. Yeah, that old. But get this, wine wasn't for everyone. Nope. Wine was reserved for royalty and priests. You had to be on the VIP list to sip on this ancient beverage. Fast forward to the Romans and the Greeks. They used it for the sacred rituals, but the real MVPs in wine history was the Egyptian. It's the first civilization that documented winemaking. Talk about the setting the foundation. Now, on to vinegar. Legend has it, some Babylonian left their wine in a storage a little too long, and voila! The wine turned sour, giving birth to vinegar. This wasn't just a simple kitchen staple. Oh no, friends. Vinegar was a superstar used for medicine and preservative.
Now, let's break down the science. Fermentation is a biochemical process where microorganisms, like yeasts, convert sugars into alcohol and carbon dioxide. In chemistry, it is usually denoted by this chemical equation. One molecule of C6H12O6 breaks down into two molecules of CO2, also known as carbon dioxide, and two molecules of C2H6O, also known as ethanol. But this is a simplified version of the reaction. So you might be wondering, how did we get this chemical formula? First, glucose undergoes glycolysis. It breaks down into two molecules of pyruvate through a series of enzymes such as hexokinase and pyruvate kinase. One molecule of C6H12O6 breaks down into two molecules of C3H4O3. Then one carbon will be removed through an enzyme we know as pyruvate decarboxylase, also known as PDC, from two molecules of C3H4O3 in order to produce two molecules of C2H4O, also known as acetaldehyde. This process also produces two molecules of carbon dioxide which will be released, giving us a final chemical formula of two molecules of C3H4O3 breaks down into two molecules of C2H4O and two molecules of carbon dioxide. Finally, two molecules of C2H4O will be reduced by NADH and also with help of an enzyme called alcohol dehydrogenase, also known as ADH, to produce one molecule of C2H6O, or more commonly known as ethanol, an essential ingredient for alcoholic beverages. The chemical formula for this process is denoted as two molecules of C2H4O plus NADH breaks down into two molecules of C2H6O plus NAD+. Note that this process would not have been possible without the help of enzymes. They reduce the energy requirement for a chemical catalyst, making chemical reactions more efficient. Whew, that was long and tiring. Let's give our brains some rest and move on to the exciting part.
Now that the boring part is over, ready your lab coats, wear your safety glasses because we're about to get scientifical. This activity is sliced into two parts, Phase A or the alcoholic fermentation and Phase B, the acetic acid fermentation. Today we'll be showing Phase A. The purpose of Phase A is to break down glucose without using oxygen to produce ethanol or alcohol.
Before we start, we should first prepare the needed materials to perform this activity. We need clean cheesecloth, coconut water, brown sugar, yeast, funnel, bottles, any kind of stove, and cooking pan. The first thing we should do is to filter the coconut water using the cheesecloth. We do not want any foreign particles that may disturb the procedure. After that, we can now place it in a clean cooking pan. Then we can add 2 cups of brown sugar. Sugar is an important part of this experiment. More sugar means more food for our yeast after all. When the sugar is added, mix it well using a spoon until all the sugar dissolves. When all the sugar dissolves completely, the next thing we can do is heat the mixture with a low fire for 20 minutes. After heating for 20 minutes, we can now let it cool for 30 to 60 minutes.
Now that the mixture is cool, we can start by adding half a teaspoon of yeast, kickstarting the reaction. Remember to mix thoroughly. After this, use a funnel to transfer the mixture to a clean transparent bottle. Do not forget to cover the bottle with cheesecloth. This will allow the gas inside the bottle to live. Finally, place the mixture in a secure place. We have to wait for 1 week before adding the mother vinegar.
Welcome back! 1 week has passed and it's time to move on to Phase B, acetic acid fermentation. What exactly is the purpose of acetic acid fermentation? Well, the goal of this phase is to convert ethanol from our alcoholic fermentation to acetic acid through fermentation. This is possible through bacteria, specifically acetic acid bacteria or AABs. These little guys oxidizes ethanol using oxygen to produce acetic acid. This chemical reaction can be denoted as this chemical equation. Again, just like in the alcoholic fermentation, this reaction will not be possible without enzymes. Now, to further understand the formula, let's try expanding it. First, ethanol is oxidized to acetaldehyde through alcohol dehydrogenase, an enzyme. This chemical reaction can be denoted as this chemical equation. Lastly, acetaldehyde will then be converted into acetic acid through an enzyme called aldehyde dehydrogenase, giving us this chemical equation.
Now that you know about the point of Phase B, let's get experimenting. The very first thing you should do is prepare the needed materials. You'll need a jar, 2 cups of mother vinegar, and cheesecloth. First step, safely pour the mixture into the jar, then add 2 cups of mother vinegar. After this, cover it with the cheesecloth and put it in a safe, secure place. Then that's it. The next thing we will have to do is to be patient and wait for 1 month to pass before transferring it to the vial.
Hi! It's been a long time. A whole month has passed and it's time to move on to our final procedure, the transferring of the product to a vial. We first need, of course, the vial, then a funnel, and a ladle.
Put the funnel into the vial to avoid making a mess. Then using the ladle, safely pour the substance into the vial. Then, we are finally done. We have successfully created acetic acid.
A reminder, we must remember to follow the instructions to avoid any unwanted events such as protein denaturation. Protein denaturation is a phenomenon where the shape and structure of the protein breaks. This can be caused due to pH level, heat, acid, and more. That's why we should follow the instructions, especially the assigned temperature, as this can cause protein denaturation in the enzymes, slowing or possibly stopping fermentation completely.